video, maybe? Yeah, okay, let's do this also. So I've just brought in the test data for today's assignment. And the task is to find, well, basically this one. And the task is to find basically turns down for the index, or rather the position of the end of the first unique 4-character sequence. I've got my data here. I've got playground set up, and I can probably do this. So I'm going to do this line by line. And I'm probably going to just print input lines mapped over this function. Let's see if the framework worked, rather the scaffolding. Yeah, okay. So I have the line. I need to find first 4 characters unique sequence. And I probably want to use a set. Well, I guess I'll try the ineffective approach, the sort of brute force approach, and then maybe try to do any optimizations. So what I'm thinking I can do is on each character, starting from the position 4, so I'm going to guard that line count is greater or equals to 4, else I'm going to do fatal error here. I'm going to look 4 characters back, and if those are unique, then I'm going to know that this is my answer. So let's see how it goes. Okay, so current index would be equal to 3. That's the 4th position, right? And for I in current index, and I guess I can just do current index and 3 to the line count, and I'm going to take a slice, would be line this is super ineffective, but I'm going to do array line current index plus 4. No. Current index minus 3 to minus 4. Okay. So I want to do a range here to make to get a slice, right? So I want to do like this to current index. So it would be for the first one. Okay, so for the first one it would be 0 to 3, I would guess, right? And I can just take a set. Set would give me unique characters already. So if set of slice count equals to 4, we have 4 unique characters. I'm just doing return current index. And if I ever reach here, I do fatal error, because I always expect to find that character. So let's compare this with my input data. It's 7, 5, 6, 10, 11. Looks good to me. Let's see the puzzle input. Okay, we have just one long line. Okay. So it's 1929. Okay, first part is done. Part 2. Your device's communication system is correctly detecting packets, but still isn't working. It looks like it also needs to look for messages. A start of message marker is just like the start of packet marker, except it consists of 14 distinct characters rather than 4. So here it's 19. Do I just changes this for... Yeah, let's try stupid approach. I'm going to change this for like 4 14. And this should really, like 14 could really be length, right? And if it works, then yep. Right. Perfect. Day 6 is done. Can I do day 7 right away? Like, I mean, day 6 was way easier than day 5 was. It's been basically like 8 minutes of work, right? After messing with the stream setup. Day 5 was really challenging. Let's take a look at day 7. You can hear birds chirping and raindrops hitting leaves as the expedition proceeds. Occasionally you can even hear much louder sounds in the distance. How big do the animals get out here anyway? The device the elves gave you has problems with more than just its communication system. You tried to run a system update. Okay. System update please, pretty please, with sugar on top, error no space on device. Perhaps you can delete some files to make space for the update. You browse around the file system to assess the situation, save the result in terminal. Output your puzzle input, for example. Do I smell a hash map here? So we have cd/ls dir a blah 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 blah. Okay, no. We dir a and 2 files, dir d. So we have 2 directories, right? cd_a, ls, directory e. It's a tree, right? The file system consists of a tree of files, plain data, and directories which can contain other directories or files. The outermost directory is called /. You can navigate around the file system, moving into or out of directories and listing the contents of the directory you're currently in. Within the terminal output, lines that begin with $sign are commands you executed. Very much like some modern computers. Cd means change directory, thank you. This changes with directory in the current directory, but the specific result depends on the argument. The X moves in one level, it looks in the current directory for the directory named X and makes it the current directory. Cd dot moves out one level to the parent. It finds the directory that contains the current directory, then makes that directory the current directory. Cd/ switches the current directory to the outermost directory. / ls means list. It prints out all of the fields and directories immediately contained by the current directory. 123 abc means the current directory contains a file named abc with size 123. Dir xyz means that the current directory contains a directory named xyz, right? Given the commands and the output in the example above, you can determine that the file system looks visually like this. So /a d, right, a and d in two files, b and c, right? Right, b and c. Then we have dir a, cd, cda, and ls. We have e, 3 files, and here they are. D has just 4 files, right? Right. And this also has E, and E has 1 file. Okay. So here there are 4 directories. They are most A, D, E. These directories also contain files of various sizes. Since the disk is full, your first step should probably be to find the directories that are good candidates for deletion. To do this, you need to determine the total size of each directory. The total size of a directory is the sum of the sizes of all files it contains directory, or directly or indirectly. Directories themselves do not count as having any intrinsic size. Yep. I'm getting nervous. The total sizes of the directories above can be found as follows. The total size of directory E is 584, a single file. Yep. Which one? This one. The A has 94853 because it contains files F, G, H, I. Well, I would just trust that this one sums up to that. And D has total size of this because there are 4 files. Okay, as the outermost directory contains every file, its total size is blah blah blah. This sum. Okay, so to begin with, find all of the directories with a total size of at most 10,000. Then calculate the sum of their total sizes. In the example above, these directories are A and E. So A total size is 94K, and D total size is basically 24 megs around. Sorry, at most 100K. At most. At least 10K, at most 100K. So let me just double check. D is 24 megs and we're looking for 100K. So it would be this one, A plus E, right? Yeah. And their total size is 95,437. Wow. Well, this one is kind of challenging. Well, I have to build a tree. Let's see how the input looks like. Well, wow. To be honest, I'm pretty nervous. Let's try to start with something, I guess. So I'm going to name this list of commands. probably need current dir, and I'm start with slash. I'd probably need storage, and I'm going to use a simple hash map, I guess, and can the directory's name have a duplicate names? Because in that case I might need to build a tree, not hash map. Hash map might not be able to cut it. So let's see, cd okay, let me take this, bring here. I'm just going to look for all the cities, and then I'm going to do /, and this is going to be my group. So okay, now it would be great to filter out something that is not starting with this. So I probably would need to do some negative look ahead for the regular expression. Does it go like this? And starts with this one. So probably should go with this. Regex does not start with. So yeah, it has this here. And then question mark, exclamation mark, right? Am I doing this right? Negative look ahead, yeah, this is what I need. So I need... Okay, let's just remove the start requirement. This... Oops. Okay, why does not it work? Well, it kinda does, it just does not highlight it for some reason. Okay, but we can replace this with this, and we got all our CDs. No. Do I need to do then? Yes. Okay. And now we finish with so we finish with $sign. Okay, this is something. So I'm going now to remove the the duplicate lines. I'm also going to replace the dots. And there's gonna be this just to match the whole line. Once again, I'm going to clean the the empty lines. Okay. So I have 206 cities. What I really wonder is, are those unique or are those not? I'm going to copy all of this into a new file, and I think my editor had a unique or duplicates. 206. I want to do leaving line. Okay, yeah, well, I definitely have some duplicate lines. I might need to build a tree. Should. Am I streaming? Yes, I am. wonder how it looks. Find the first duplicate line. Okay, so this one. How is it being used? Is it truly a duplicate? So I find the first one. I can copy this to a new file. I can copy my input. In this, well, currently I'm trying to just find out, can I get away with HashMap or not? Or to build a proper tree. So we have dir, we have cd, ls, dir, blah blah blah. This is not city, this is city. GQDDDS. Yeah. Well, it looks like I'll have to do this the hard way. Shoot. Okay. Okay. So I need a tree. Can I do with a struct tree node? Or rather, yeah, tree node, I guess might be okay. So we can have more items, or we can have just more files, maybe, which would be just let's try with the name and size. And there's which will just be names at this point, array names, or we can have set of names, I think. So current dir is this, and what am I looking at? So I'm starting with actually dirs should be tree node, which basically has a name also. Let's see if I gotta conform this to hashable. Okay. So now for command and commands, now comes the hard part. So command could be cd, ls. Well, it's not technically a command, it's line. It could be a command, or it could be an information line. Have CDs that change a couple of levels. Well, in mine, no, I can just see the one level. So if line starts with this is a command. I guess ls could be just like this. Okay. So if line is ls, what do? We have to add this information to the current dir. I think we gotta use classes here, and would be better if we can do links. So it has to have a name, it has to have a parent, because we need to navigate up one level. So it's tree node optional. Why optional? Because the root node would not be parent. Okay, so let's make this less. We have an initializer, which would be name and the parent. And the files and dirs, I guess, would just be filled later. Okay. So this one has a name, but it has no parent. This is the root, and we can also current tree node, which also equals to the root when we start. Okay, so for if line equals ls, I guess we just don't do nothing, we continue. If line does not start with $, we process the line, which basically, once again, if line starts with dir, I'm going to let dir name child dir name. I'm going to take child dir name and what? It would be line replacing occurrences of dir with nothing, and current dirs insert tree node with well, I guess not technically insert. If current dirs. So if we, at this point, if we not have a child with this name, we should insert it. Otherwise, we should really do nothing, in case this is like a second entry to this location, right? Nothing really prevents us to enter in the same dir again. So let's see. If current dirs contains child, contains where name equals to child dir name, we just continue. Otherwise, we insert, and there's going to be a tree node. Name is going to be child name. Person is going to be current. Yay! So next one, file. We have size and we have file name. I guess it's getting a little bit simpler. Let's try. So right. We split the spaces. We don't have spaces skipping in this file system, right? I don't think we do. All the spaces we have are right. Okay. So I'm going to assume that we do not have file spaces skipping. So if one does not start in dir, and this is like a main line, we basically need to enrich our current node, so we are going to parse file. So file info array is going to be line component separated by space, and let file size would be int over file info array or fatal error if we cannot do this, and let file name would be 0. Now once again guard file info array size or count or count. I always 2 here, right? Then I'm going to just take file size and also do this. Also I'm going to just bail out. File name is always going to be the second item of file info array. So yeah, this is by the way not resilient at all. But let's see if it works. And then what we can do is, I guess we can override. So we can do the current files over file name and size equal to file size. Okay, so it's to be equatable. I guess I can do the object identifier trick here, so I can just do this. And in this case, this should be sufficient. I don't need a deep, you know, I'm going to do extension over gnode, over equatable conformance, do this, and yeah. So hashable, what's up with that? Okay, maybe it's not happy. Let's try to move this here for now. Playground sometimes are behaving not in a great way. Let's see if this works. Does it build? So it does not conform hashable. So okay. Isn't supported. Okay. Which 3 node conform blah blah. Oh my god. Okay. So how do we conform to hashable? It's just hash into hasher. Okay, I'm going to Google that. How to conform to hashable. Yeah, based on object reference, this does sound good. Okay, this one. Okay. So it's hash combine object identifier self. Yes, I think that's what I'm looking for. I'm just going to use object identifier. This does build. And now to make things a little bit tidier. Yes, as much as they be, provided that we are using playground. I'm going to move this here, and I'm going to move the conformances over to the extension. Does it work now? I'm getting fatal error. Okay. So I'm going to print maybe file for array just to know where we're failing. So it's dir A. I need to continue here. Right. Okay. Okay, looks like we're good. So yeah, then we continue once again. We could match this logic, but continue. Now this is the simple part. If line starts with CD, I'm going to do this piece of logic. Here I'm going to tell error because we don't expect anything else. Here I'm going to continue. And yeah, and what? Now we just need to change our current. So if, let's do their name. This would be line replace occurrences of this with nothing. This is their name. I'm probably going to extend this, but not this much. Just want a little bit more space over here. And if their name equals to that dot, then I'm going to guard that we have parent. Else we're going to tell error. This case might only happen if we are trying to go to parent from the root, and this is not going to work. It's not supported. And here we just current equals to parent. Otherwise, we are going to find the one guard let child equals current dirs. First, where name equals to that dir name, else fatal error. That's kind of nice error handling, right? Super easy. And current would equal to that child. So we should probably have a tree, but we're not having it, and we're fatal erroring here. Why? not sure to get into this point. So we're doing continue here, we're doing continue here. Where do we fail? I'm just going to check this one and this one, so that I know it's somewhere in the layers. It's got to be over here. Okay, so print child and line, and print parent. I guess it's not gonna help us in the parent case, but this will know where it fails. So it's not that. Oh no, okay. It's, yeah, we have this corner case of CD slash, right. Okay. So else if dir name equals to this, we just switch it back to root. Right. Okay, so we have something. Now we probably would have to walk the tree to calculate the sizes. This one's quite massive, right? And I need to walk the tree from bottom. From the bottom up. How can I do this? Let's make a function. The tree. I'm going to do sizes over tree node int just to calculate the sizes. So I'm going to do node so I have to do this recursively and start from bottom child. So okay, so for node dirs for each, we're going to walk the tree. And then for the terminal case, I'm going to do sum. So it's files map. Okay, node files map what? Just value, I guess. And I want to sum these. Okay, reduce 0 plus, so it let total file size would be this. That total child dir size would be sizes. Okay, so it's gonna be dir sizes. So dir size is for, okay, so node dirs map dir size over the node. Once again, let's confirm that I have a value here. If I don't have size, I do fatal error. Otherwise, I return size. And I'm going to reduce this 0 plus. So when I sum, I'm going to return here. Well, not return, but I want to do their sizes for the current node would be file plus total child dir size. So walk the tree from root. Don't tell me it didn't crash. Okay, dir sizes. And okay, so no, dir sizes for each. I'll print key value, key name. Right. Okay, let's compare this with our example. So E is 584. Root is 483.81165. D is 249 blah blah blah. Oh my god, it works. I don't freaking believe this. Righty. Okay. So now what I want to do is I want to filter. I can do just dir size map value filter included is basically size is less than, was it 100k? Yep. Reduce to 0 plus let part 1 equals this, and I will print part 1. 95,437. Now the glory time. We have this value. Let's try it out. Unfreaking believable. Let's go to part 2. Yeah, this is kind of a challenging task. Now you're ready to choose the directory to delete. The total disk space available to file system is 70 megs. To run the update, you need unused space of at least 30 megs. You need to find a directory you can delete that will free up enough space to run the update. In the example above, the size of the outermost directory and thus the total amount of CPU space F is 48 megs. This means that the size of the new space is currently this, which is quite the 30 megs required. Outermost directory, which is what is outermost directory. So it's slash. Therefore, the update still requires a directory with total size of at least 8 megs to be deleted before it can run. To achieve this, you have following options. Delete E would increase by 5 stars from the smallest, right? E and A are both too small, deleting would not free enough, so directories D and slash are both big enough. Between these should the smallest be increasing the unused space by, okay, find the smallest directory that F delete would free up enough space on the file system. So we find the smallest directory that is big enough to free up enough space. Okay, so let's see. We have the size. Let needed space. Let's find the needed space, which is basically dir size. So we have 70 megs minus 70 megs, right? Yep. Overroot, I'm sorry. So let's guard let root size, or can I do just here minus or fatal error? Would this work? Does not. So let's guard let root dir size equals this one, else fatal error. Man, I love this exercises. I could not imagine the error handling bees in a production product. I still try not to force unwrap and check my assumptions as I would normally do in the production code. But this ability to just not handle the corner case, just to tell a roar is so cool. I'm really doing this. Okay, so root dir size. Now we are also guarding against that needed space is greater than 0. Let's try greater than 0. Else we do fatal error again. It. And now what we need to do is let's sort the dir sizes from smallest to biggest. So let's sizes. Well, dir sizes values sorted by this. Would it render the... Okay, let's just print first. I wonder if it's a big or large. Okay, yeah, it looks like it's we're sorted the correct way. Yep. So we need to free. What is our just what is our root dir size? Our root dir size is 46 megs. And needed space is respectively 23 megs. Right. So I'm sorting this from smallest to the largest, mapping. I'm not getting the first. I'm just going to find the first where this is greater than or equal to needed space. And this is going to be part 2. And I'm going to print the part 2. And hopefully now I will get my star. No! Too high. Why is that? So our needed space is around 23 megs. Maybe I misinterpreted the assignment. E and A are both too small. So E and A, okay. Okay, what am I doing wrong? Let's try with sample data first, I guess. See how this would work. So we get 24 something 93642. It was. At least 30. Oh my god. At least 30, not 70. So this is the needed space. This is the free space. And needed space is is 30 megs minus free space. Let's also, yeah, we are checking that. And this is 24 megs then. Okay, let me put, yeah, so there is an update size and I was looking for folder that's larger than available free space. In this case, 7 megs. Let's try this one. This should work. This should work. Yes. Yay! Yeah, well, this was challenging. This one was genuinely challenging. Well, I guess this is going to be enough for today. 2 assignments, good enough. Hopefully I'll have some time to nail down 8 and 9 and 10 tomorrow. Thank you for watching.